One important consideration that you have to take here is the free body diagrams. Problems in mechanics always involve the interaction of bodies on one another. Successful solution of these problems generally requires that bodies be isolated from one another so that forces involved may be analyzed and unknown forces determined. So, for example, you have here a certain body, and then there you can show the free body diagram using this area, that body, and then you have here the weight going in this direction due yeah, to the gravity. Due to gravity, it's going downward. And then if you have here a flexible cord with a rope connected or a cable connected at a certain uh, structure, then you have this body with a certain angle. Then you can represent it with the angle theta, and then you have a retention load in this direction. And then you also have here for smooth surface inclined even in a given plane with an angle of theta. Then it could be represented in this manner. Take note that it's always, if you have this angle, this one is always theta. So it could be represented in this manner, by which from it could easily be calculated and determined by reactive elements. Now if you have a ruler, obviously you only have here one reactive element going upward. And for smooth pin or hinge, you have here, of course, you have two reactive elements in vertical direction and horizontal direction, and going in these directions since it supports the load of this one. So it goes in upward and in right direction. So for example, you have your system of cords knotted or tied together at A and B. It's knotted or tied here at A and B, being supported from the ceiling, and then maybe other side is from the wall. You are asked to compute the tensions P, and then you have your Q, F, and P. So we're going to draw the free body diagram. Of course, here is you have here the P, which are in tension. Similarly for T is also in tension, F is also in tension, Q is being supported from this wall is also in tension. Then we take first this part, get a free body diagram. So we'll be represented by here. And there are several methods that we could show, you could choose for your convenience. First method, you just have to consider the equilibrium equation. So you have to sum of forces along X. Okay. So our consideration going to the right is positive. So you have P, cosine of 15 is the horizontal component. And then you have minus Q because it's in opposite direction. Take note, here is negative, going here is positive. So Q cosine of 30 equals to 0. And then you also have P going up for vertical forces along, or for forces along Y. That's just sine of 15 here. And then for Q, you also have going up, which is also sine of 30. And then going down, it's 300. So from here, by simultaneous equation, we can use your calculator, or we can compute using elimination. These two equations and then two unknowns. Let's say this is equation 1, this is equation 2. Then we can get P is equal to 367 and Q is equal to 310. Another method is by rotated axis. Let's say we want to rotate the axis. For what purpose that we are going to rotate the axis here? This will become the new Y, as you can see here. That is because if we are going to sum up vertical forces or sum up forces along this new y-axis, we can only have one unknown. So in this case, how we get 45, of course, here, if this is 30, if we extend this line for Q, if this is 30, this becomes also 30. So that we have 30 here, we have 15 here from that original figure. We just add 45 to make this one as 90 degrees. Then sum of forces along Y, this new Y. So you have P, it's either you use sine 45 or cosine 45, that doesn't changes its value, the same value for sine and cosine 45. Then you have negative 300 sine 60, this one going here is sine of 60, that's negative 300. Then we can compute P. And then if we sum up forces along this x-axis, we only have one value or one unknown, Q. Q is negative. P cosine 45 here is this component along the new x, and then 300 also going this one, cosine 60, and then we can have value of q which is from 0, which is the same with the first method. Other method is the simplest method, which I prefer most of the time. We do the force polygon method. For example, here 300 is going down here, and then you have your 15 and 75 for P going here, and then Q similarly you have here 30 degrees with respect to the horizontal or 60 degrees with respect to the vertical. By sine law you have 300 into the opposite, okay, opposite angle, sine of the opposite angle 45, and then you have P also with the sine of the opposite angle, and then likewise for Q, sine of the opposite angle 75, and then by simplifying further we can get P and then Q. Then after this one we can now compute the remaining values at the joint D, by which we already calculated P, we calculated P. If we sum up forces vertical along y-axis, then we can calculate F, because F is just equal, the component here, this component along y is sine 45 minus 367, this one, which is sine of, okay, here 367, this is sine of 45, this one, sine of 45, this one should be 45, sorry for that. And then you have also 200, this is, if this is 60, sine of 60, or you can also use cosine of 30, you have the same value, right? Then you have 612, and then summing of forces vertical or horizontal, I should say, along x, then we only have value of P, because F is already calculated. So P, which is exactly along the line of the x-axis, then you have 200 cosine 60, this is 200, this is 60, this is cosine positive, and then 367 negative because it's opposite direction, which is cosine 45. Just take a look of this one. I think something that you have to consider with the determination of the angle. Okay, so that's all, and thank you. Don't forget to hit the like and subscribe button. Thank you. Don't forget to hit like and subscribe.